Hey, everybody. So this is identifying malicious OSS across ecosystems. So I've had a lot of fun attending lots of the different sessions, hearing about CRA, CVEs. This is VulnCon. This is a little bait and switch. I'm going to talk about malware. I'm not going to talk about vulnerabilities at all. So welcome. Hopefully after at day 3, you're all ready for a different topic. Here we are. So who am I? I'm on Microsoft's open source security team. I do lots of things there, but my primary focus is on finding malicious open source software across multiple platforms. So your NPMs, your PyPis, your NuGets, VS Marketplace, etc. Prior to Microsoft, I primarily worked in the application security space, spent a long time building IS and REST products for .NET and .NET Framework applications. That's completely different. Catch me, afterward, and we can talk about that. But this is about malware. So, agenda for today: talk about OSS malware, why it's there, how to find it. I'm going to tell you about a research project that we're calling Assimilation to find malware across ecosystems, and then share a few results of what we found, some trends, etc. So, why malware? OSS is widely used. Everybody, I think, in this conference has trotted out that 96 or 97% of code bases include OSS. Has a low barrier to entry. Most repositories allow anyone with an email to publish packages at no cost to the publisher. There's lots of places to hide across 11 million individual OSS packages across many different platforms. And many of those packages have many versions. And then, as Michael Windsor pointed out in his earlier talk, these packages have access to your build systems, they have access to your production systems, all the valuable assets. So we're also seeing the number of malicious packages increasing year over year. OSS is growing, malware in OSS is growing right alongside of it. And since we're also seeing malware in different repositories. NPM is the biggest here, but we're also seeing large number in PyPI and a number of the other repositories. These numbers, of course, from OSSF's malicious package data set. So into sort of more the meat of the presentation, now that we understand the context of the problem. How do we find malware? Well, there's two traditional approaches. We can try and predict what the code will do with static analysis, use compiler-like techniques, build our ASTs, build our call graphs, and that's, that works, but it can be computationally expensive, and there's a lot of open source out there to apply this to. And then dynamic analysis, we can observe what the code did, run it hopefully in a sandbox, take logs in lots of different ways, but that's also can be difficult to scale, catches most types of malware, but not all, and generally requires humans to review the results. There's can be a large number of false positives generated by these tools, these approaches. So what if we wanted to find malware across multiple package managers? Static analysis, dynamic analysis, they're great, super powerful, but they're generally targeted towards a small number of languages. So what if we looked at the metadata for the different OSS packages? Look at the information about the package, the authors. So what do I mean when I say metadata? So here's an example from NPM. There's a huge amount of text. A lot of you are sitting far back in the room. I know you have no chance of reading this, but it's generally things like the name, the keywords for the package, its description, what version it has. This is a more popular package. I believe this is Express that I pulled in here. And so there's also a lot of security information in here. So what might be interesting for us if we're looking to identify malware? lots of these fields are interesting for us if we want to try and identify malware. So I threw some red boxes in here. We're not going to dive into details here. We're going to make this a slightly interactive session. I don't know how strict we want to be on the mics here, but we're going to play a little game. I'm going to give you some metadata for a package, and then I'm going to ask someone to volunteer to tell me whether or not they believe it is malware or not. So here's our first one. So fun package called Crash Handler. Yeah. All right. Why do you believe it's malware? No information whatsoever. They just left all the fields blank. One version and very high version. All right. You guys are going to be great at this game. All right. So yes, this is actually it's a namespace confusion. So there is a well-known NPM package called Crash Handler, but it's in .com reliability kit namespace. And so this attacker just said, you know what, I can publish that package just without the namespace. And if you're a developer pulling in this package, you might not pay super close attention. You might accidentally pull in malware. But yeah, one version, high version, super suspicious. But NPM also offers this opportunity to run scripts when you install the package. And so attackers love this capability. All right, on to our second example. Fun package called PDF Password Protector Util. All right, over here on the right, why is it malware? All right, so it runs a Maven command. That's super suspicious. As soon as you install it, it runs Maven clean package. Yeah. All right. Yeah, so the repo and the package name don't match. This is suspicious. We should probably take another look. We threw some tools. We used our human eyeballs. We reviewed the code in this package. It's not malware. It does suspicious things, but it's not malware. So it actually like calls out to a jar file to encrypt passwords, and it was odd, but benign. Uh, the metadata for this one, I believe, came from libraries.io, which we're going to discuss in a second. I've got 3 more rounds of this game to play, and we're going to get through that, and then we're going to get back to the academic content. All right, so we're going to call this agent base. Is it malware? All right, resounding yes. Why? Versions aren't lining up. Yeah, one version, 7.11. It does some post-install nonsense. Yeah, you guys are good. This one's malware. So this was actually typo squatting on the real agent base package. They just left out the A. Easy mistake to make. And this is actually part of a larger malware campaign. So I think there were a couple dozen packages published that all had this same technique. All right. HTTP test-CLI. We're all thinking very carefully. All right. So I like that we're not sure because this one's not malware. They're running, they packaged up Rust and then are distributing it via NPM. Weird. But it's not malware. And uh, just for those playing along at home, the ones that aren't malware, they have been anonymized, shifted ever so slightly from the real packages. But how about this guy? The last round, this package. Oh man, we are so confident this one's malware. Why? Yeah, it's typo squatting. They didn't even change the description. They left the description spelled correctly, but messed up the name. So yeah, the last one's a little bit of a gimme. They're typo squatting on Prettier, pretty popular package. They have the same repo URL. That's what clued us into this package. So yeah, and this one's also funny because a lot of antivirus would actually catch this because they included the malware as a bundled binary in the npm package. So as soon as you download it, your antivirus should yell at it if it's any good. All right, so what if we wanted to look at the metadata for multiple package managers? This was a fun little game. We looked at just 5 packages from npm. They all did some funny things. And we could certainly just scrape npm and PyPy and do this ourselves. But luckily, other people have already done this for us. So there's libraries.io, ecosystems, and deps.dev all provide sort of a neutral metadata format for multiple package managers. They all go out and scrape these package managers themselves. And this leads us into the research project that I promised I would talk about. So we chose to use libraries.io. They've got a useful API that lets us grab the most recently published packages. So we do that on a regular interval. We poll it. Then we reach out to specific registries to get any metadata that might be interesting that isn't included in the neutral format. For example, like npm's install scripts. They're pretty interesting. That's how a lot of npm malware abuses them. So we want to make sure we grab that metadata as well. We log all that, and then we run some rules against those logs and get alerts for us to then manually inspect and run tools to find malware. As you saw in our little game, we can't just trust just the metadata to accurately identify our malware. We generally always need a human in the loop to accurately identify. We have lots of ideas and plans for this system. We want to integrate with other tools. I actually just got a specific internal tool integrated to this process. Found some more malware, and maybe at next year's VolCon I'll tell you about that. But that's ongoing work. The main flow today is right here. So let's talk about some of the results that we've. Oh yes, go ahead. That is a great question. So right now we report them to the owners of the package managers. And so they generally take them down. So if we went back in time here and you went and tried to find Prettier, it will tell you this is not found. Oh no, you get a security holding package message for this npm package. Yeah, we're open to innovation on faster ways to but generally getting it removed from the package manager I think is been good enough to date. Back to let's talk about the results for what we've found so far. So we pretty frequently find packages that are trying to exfiltrate either benign or sensitive data from the local system, and lots of packages that connect to remote systems, download some script, and try to run it. A bit of crypto stealers, miners, and binaries, and lots of spam packages. So I'm going to primarily talk about the exfiltrators, droppers, and the spam packages. So back to our friend Crash Handler. So this is just a snippet of the code from this guy. So it collects information about your home system, your DNS, your IP, and then sends it off to with some Discord webhook. So some bad guy is just monitoring his Discord channel, watching machines report in that have installed this package. We've also seen packages that try to collect browser passwords, other sensitive data from the local system. Our friend Agent Base. So here's the code. This is pretty typical of the code that we'll see in this malware style packages. They ran it through an obfuscator. We've got, not a ton of ideas of what to do here because it's also very common to ship minified and obfuscated code in just legitimate packages. Luckily, you know, good security people, the ecosystem have wrote a number of deobfuscators so you can get to reasonably readable code. So this is a snippet of the deobfuscated code, and it connects to a Ethereum wallet to get an IP address, downloads a script, and then executes the script. And then there was some intelligence in the obfuscated code based on operating system, but I just kept the Windows bits in here. All right, so let's talk about some of the spam campaigns that we've seen here. So we had a number of packages come across our desk like this. NPM helpfully has this capability to display your README as if it's a web page. And so bad guys said, great, I'd like to use your ability to display web pages for free. And when you clicked on a link in that web page, it took you to some advertising referral link loop. So anytime a victim would click on one of these, they'd get taken to another advertisement and another advertisement and so on and so on. And presumably, bad guys are making fractions of a penny, but they're making fractions of a penny for free. So they're very happy to just upload garbage packages. We were not the first to observe this. It's not new or novel. There have been news articles. Most of the packages were published in 2023. This doesn't seem to be ongoing. And this is not necessarily traditional malware, but it's definitely, it's spam. It erodes trust in the ecosystem. And, package managers don't want to host this stuff for free. So we're happy to report it and get it removed. Yes, question. So the question was, do we see this as a targeted attack or just a broad phishing, let's see who falls for it attack? I would say it's more the latter because the names on these packages are literally just like, hey, here's a popular ebook. Come click on this link to get the ebook for free. I don't think they're trying to look like software. They're just trying to host free web pages. Follow-up question. Yeah, so just to repeat for people on the mic, audience member here is their organization is seeing spam packages, typo squats for packages that you use, but they've largely already been taken down. So I will say that I can't speak to whether or not the folks maintaining NPM see that. We collaborate with the folks at NPM, but this is more of a independent effort to find malware across the ecosystems. But I'd be happy to, talk to the folks at NPM and see what kind of, telemetry observability they have into malicious packages targeting specific organizations. I know that I've got about 8 minutes left, and I want to make sure we get through the last part of this spam packages, and then we'll wrap up, and then I'm happy to take more questions. So as we mentioned earlier, we have a number of alerts that look at the log data. And, as mentioned earlier from Microsoft, we have some rules that look for packages that might be trying to impersonate Microsoft. One of our, special words is Azure. And this package contained the word Azure, married Azure Swan, but you can imagine the random name generator that created this. And so it came across our desk, we looked at it and said, this has a lot of dependencies and we don't recognize any of them. So we dug into one of these packages and it's D Saturn Gall 45 and it has 42,000 dependent projects. That's not reasonable. It also contains this t.yaml file. So we went and learned what a t.yaml file was, and it is part of this T protocol. Open source sustainability is a real problem, and we totally appreciate the efforts folks are spending trying to address that problem. The T protocol is one effort in that area. And so they propose we'll make crypto payments to people based on their T rank, and their T rank is largely based on the number of dependents for that project. And so we just invited bad guys to make fake projects and make tens of thousands of dependencies on them. So these are screenshots from the T protocol's website. You can see at the top up here, Next and Busboy, like reasonably popular packages. LeftPad is up here. We remember a few, issues about LeftPad in recent memory. And then our friend dSaturnGall 45, it's ranked low, but it's ranked. And so presumably they're receiving some sort of payment from the T protocol. So again, not traditional malware, platform spam and abuse. We worked with NPM to get 47,000 plus packages removed. This is not necessarily new or novel. Other folks had covered this in the news, and even on the T protocol site itself, people were complaining in their forums. Almost all of the packages that have the T protocol are garbage. How is this useful? But this came through our assimilation research project, and it was interesting to dig into. So lessons learned. Automation is necessary to find malware across ecosystems, but it's not sufficient. We still need human eyeballs, further tooling, further innovation. Attack techniques evolve. So some of the rules that we used, that used to produce lots of results now are producing fewer. We continue to iterate on those rules and detection techniques. Attack techniques are common across ecosystems, lots of data exfiltration, lots of droppers, but of course the implementation differs. And attackers will abuse any platform that allows them to freely automate money-making schemes, even if it's just for fractions of pennies. Recap, we talked about OSS malware, why it exists, how to find it. Told you about our research project and shared some of our results. And since I know many folks here are deeply interested in supply chain security, if we have one call to action, it's attackers are publishing more malicious packages every year. Repositories lack the means to identify all malware. So consider how you're securing your organization's supply chain against OSS malware. Now, I have to mention that the folks that own and operate the different package managers are constantly evolving and doing all they can to reasonably protect users from malware. But this is a collaboration with everybody who uses open source to protect against the open source malware. Also would like to acknowledge there's been lots of prior work on identifying OSS malware, both in the open source space. Don't have time to go through all of these projects, but wanted to call them out. I'm sure the slides are available so folks can check them out. And then there has also been a large amount of academic work done in this space. Lots of good results in these papers. Check them out if you're interested in this area. And that is it. Feel free to reach out to me on LinkedIn. Thank you, everyone. And I'll take any questions with my last 2 minutes. Yeah. So I would consider that more of a derived metadata. So if a package is suddenly downloaded tens of thousands of times within some time frame, like since it's published, then that would trigger a further review. But just having a package that is downloaded lots of times isn't necessarily interesting. Right? Yeah. 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 No. You're totally fine. Other questions? Yes.
The software that Microsoft relies on, like firmware for your notebooks. Have you reviewed things like Piano Core?
Personally, no. And I will also claim ignorance as to Tiano Core and notebook firmware. That's outside my area of expertise. Yeah. Well, just me personally. I'm not speaking broadly for Microsoft. What? So I'm on the open source security team. Yeah. Yeah. So
Lots of distributed domains. Firmware security has a completely separate organization from what we are. So,
yeah. Sorry. Yeah. I should talk about the org structure, not in specifics, but just like that's outside. Yeah. All right. And I think one more question in the back there. So just repeating for the question, why didn't I talk about Socket? Their whole thing is finding malware and NPM packages. We're primarily interested in finding packages across ecosystems. NPM is definitely like the biggest target. Appreciate the work that Socket does. I just wanted to focus on our work. Yeah. All right. Awesome. Thanks, everybody.